up, everybody? This is Tech G back with another video. And in this video, I'm going to be explaining to you exactly what software-defined networking is, in case you have no idea. So let's get into it. If you've been around tech circles, especially in the world of networking, cloud computing, or data centers, then you probably heard the term software-defined networking or SDN. Now, this can sound futuristic, right? Well, that's because it kind of is. So in this video, we're going to explore what SDN actually is, why it's such a big deal, and how it's changing the way we build and manage networks. And don't worry, this isn't going to be some dry technical white paper. I'm just going to try to keep everything fairly easy to understand so you can comprehend. So with that being said, let's go. All right, so before we can understand what software-defined networking is, we need to talk about how networks used to work, and in a lot of places they still do. So in traditional networking, devices like routers, switches, and firewalls, they are the core of everything. These physical boxes contain both the hardware and the software needed to manage network traffic. So if you wanted to change something like reroute traffic or apply new security policies, then you'd have to log into each individual device and configure it, often using the command line interface. Now that might not sound so bad until you realize that enterprise networks, they can have hundreds or thousands of devices. So imagine manually configuring all of them. Now, why did this become a problem? Well, as networks grew in size and complexity, a few key issues started to pop up. There were too many devices to manage manually, slow response to changes or outages. You had vendor lock-ins, such as Cisco hardware needing Cisco tools. And then there was a lack of flexibility in adapting to cloud services, mobile devices, and the Internet of Things. And that's where SDN steps in, because it kind of helped present a better way of doing things. Exactly what is software-defined networking? Well, here's the so-called official definition. So SDN, this is an approach to networking that separates the control panel from the data panel, allowing network management to be centralized and programmable. So let me go ahead and break that down. So you have the control panel versus the data plane. So every network device, like a switch or a router, it has two key functions. You got the data plane, also known as the forwarding plane. And this is the so-called muscle, meaning it moves packets from one place to another based on instructions. And then you have the control plane, and this is the brain. And this decides how packets should be forwarded and installs those instructions into the data plane. In traditional networking, both of these are tightly coupled inside the same box, but in SDN, you can split them apart. So why do they do this? Well, instead of every device making its own decisions, we use a centralized controller, which is a piece of software to manage the entire network. And these devices, such as your switches and routers, they become quote unquote dumb in a sense, where they just do what the controller tells them to do. And this means that network administrators, they don't have to log into 100 different devices to make a change. They can just talk to the SDN controller, which handles everything behind the scenes. So think of it like air traffic control, but for your network. All right, so now that we understand the concept, let's talk about why SDN matters. Well, you have centralized control. So imagine managing your entire network from one dashboard. You can apply policies, configure routing, monitor traffic, and react to issues all from a single place. And this isn't just more convenient, it also reduces human error and makes networks more secure and agile. Then there's programmability and automation. So since SDN is software driven, you can write scripts or use APIs to automate tasks. And that includes deploying new services, changing network paths, enforcing security policies, and running diagnostics. So there's going to be no more SSHing into 12 routers and typing the same command over and over. You just write code and let the controller do its thing. There's also scalability. So as your business grows, so does your network. And SDN makes it easier to scale because the controller has a global view of the network, meaning it can optimize routes, balance traffic, and allocate resources more efficiently than humans ever could. There's also vendor neutrality. So many SDN solutions work with open standards, which means you're not stuck buying from one vendor. You can mix and match hardware from different manufacturers as long as they support SDN protocols like OpenFlow. And then there's security and visibility. So since everything is centralized and programmable, you can enforce security policies consistently across the entire network. Plus, the controller can detect anomalies and reroute or block malicious traffic in real time. All right, so let's step away from the theory and look at how SDN is used in the real world. So you'll find SDN in data centers. So modern cloud providers like Amazon, Microsoft, and Google, they use SDNs to manage their massive data centers because they need to move terabytes of traffic per second, spin up thousands of virtual machines, and respond to demand on the fly. And SDN, this lets them do that efficiently, automatically, and securely. There's campus networks. So universities and enterprise campuses, they use SDN to manage student and staff traffic, separate guest networks, enforce security, and monitor bandwidth, all from a central controller. Do you have WAN optimization, which is also known as SD-WAN, or software-defined wide area network. And this is basically SDN for wide area networks, such as branch offices, remote sites, and other things like that. So instead of relying upon expensive MPLS circuits, companies that can use SD-WAN to dynamically route traffic over cheaper broadband or LTE or 5G links. And SD-WAN, this is one of the most popular software-defined networking use cases today. All right, next, let's talk about the core components of SDN. So what makes SDN actually work? So you have what is called the SDN controller. And this is the brains of the operation. It talks to the network devices and tells them what to do. It also exposes northbound APIs, which applications or administrators can use to program the network. And popular SDN controllers include Open Daylight, you have Open Networking Operating System, Cisco DNA Center, and VMware NSX Manager. Another component is southbound APIs and protocols, and these are the communication protocols between the SDN controller and the physical or virtual devices. And the most well-known is OpenFlow. And basically, these allow the controller to program the forwarding behavior of the devices. And then you have what are called northbound APIs, and these allow external applications or tools like monitoring or security applications to talk to the SDN controller. And that's how you get things like automation, dynamic policies, and custom dashboards. And here's a quick comparison sheet to help you see the differences between SDN and traditional networking. So go ahead and screenshot that and get it in your life if you need this information for whatever reason you need this information for. Are there any downsides to software-defined networking? Well, of course there are, because no technology is perfect. And one downside is complexity. So SDN, this amplifies operations in the long run, but setting it up can be complex because it requires new skills, new tools, and new ways of thinking. There are security risks. So while SDN can improve security, it can also create a single point of failure, which is the controller, because if that gets compromised or fails, the whole network could be in trouble. That's why redundancy and secure coding practices are essential. Then there's compatibility. So not all legacy devices support SDN protocols. So if you're working with older hardware, you may need to replace or upgrade it. And then there is a learning curve. So for network engineers who are used to the command line interface and box by box management, transitioning to SDN, this can feel like a leap into the unknown. But regardless of all that, it's still worth learning. Who should learn about software-defined networking? Well, if you're in IT, especially in networking, cloud, cybersecurity, or DevOps, then you should absolutely become familiar with software-defined networking. And the reason why is because it's a hot topic in certification exams like CCNP, AWS, and even CompTIA Network Plus. Many employers, they are adopting SDN solutions to modernize their infrastructure. And SDN knowledge, this helps bridge the gap between networking and software development, which is a powerful combination. Also, if you're a student or a beginner, you can start by learning basic networking, by learning IP routing and switching. You can learn network automation like Python and APIs. You can learn OpenFlow basics, and you can do some hands-on labs with tools like Mininet, Cisco Packet Tracer, or GNS3. All right, so let's talk about the future of SDN. So we're seeing a massive shift in how networking is done, and networks are no longer static hardware-driven infrastructures. Instead, they're dynamic software-defined platforms that can adapt in real time. And the SDN movement is a part of a broader trend when it comes to things like infrastructure as code, cloud-native networking, network function virtualization, intent-based networking, and zero-trust architecture. Now, when it comes to all of that stuff I just stated, SDN plays a foundational role in all of it. All right, so let me go ahead and wrap all this up. So exactly what have we learned today? Well, we learned that SDN stands for software-defined networking. It separates the control plane from the data plane. It gives you centralized control, automation, flexibility, and better visibility. It's used in data centers, campus networks, cloud platforms, and SD-WANs. And it has some challenges, but the benefits far outweigh the risks. So whether you're a network engineer, a system administrator, a cloud architect, or just a curious student, SDN is something that you'll want to understand as networks continue evolving.